morning to everybody and welcome to another video on my YouTube channel. Today in this video we are going to be solving this particular problem on electric field. And so this unique problem will evaluate our knowledge and understanding of the electric field strength. So if you're a physics student at the GCE advanced level, or a physics student, a student going in for competitive entrance examination into professional schools in Cameroon and abroad, then this video is going to be of special help to you. Before you get started with the video, I will recommend that you subscribe to this channel, and after watching the video, if you like the video, I equally recommend that you like the video and make good comments about the video. Let's get started. I am Sir Godwill, YAKUM. The question reads: two particles carrying charges Q1. So I will develop a solution. I am going to take down the given information, collect my data. I have that Q1 is 4.0 microcoulombs. I have that Q2 is, and Q2 negative 3 microcoulombs are placed at a distance of D, let me say D, or R, I use D, 5.0 times 10 to the negative 2 meters apart. Roman 1 says sketch the electric field lines between Q1 and Q2. So I am going to, je vais d'abord porter le schéma. I'm going to have the first charge here. I'm going to represent it as a point charge, Q1, which is positive. It's positive 4.0 microcoulombs. And let me represent the second point charge here. Let me put here Q2, which is negative 3 microcoulombs. So these are the two charges, and they are placed at a distance of 5.0 times 10 to the negative 2 meters apart. Now I can indicate a distance, but now since I am trying to sketch, I want to sketch the field lines. So since I want to sketch the field lines, it's not actually necessary to be putting the distance there. In the second part of the problem, perhaps for sure we are going to be indicating the distance. Now given that the first charge Q1 is positive and the second charge Q2 is negative, now we can use this principle to indicate our field lines. We can use the principle we know already, that for a positive charge, or for the electric field, the electric field lines are generated from the positive charges and terminated at the negative charges. That means that the electric field lines will move from the positive charge to the negative charge. In other words, we know that the electric field lines are centripetal for a negative charge, but they are centrifugal for a positive charge. And so we can represent our field lines like this. Since Q1 is positive and Q2 is negative, it means that the field lines will be moving from Q1, which is positive, to Q2, which is negative. And then secondly, the field lines are going to be curved. Why should the field line be curved? Because between these two charges, from the fundamental law of electrostatic, like charges, they will repel. Meanwhile, unlike charges like the positive and the negative charge, they are going to attract each other. So based on this, we know that there's attraction. There's a force of attraction between Q1 and Q2, and that's what gives us the field lines in a curved manner that move from Q1 to Q2 straight lines. Then we should also know that the density, the electric field density, is going to be more closer to the charges, and is going to reduce as we move away from the charges. So it means that as we indicate the field lines like this, when we move closer to the charges, moving closer to the charges, you see that the field lines are closer to each other than maybe in the middle here. And we'll go closer to the Q1 charge, the field lines are still closer to each other. And the closer the lines are together, the greater the electric field density, and the greater the electric field strength. So the electric field strength is greater toward the charge. All right, that was not our aim. Our aim was to represent the field lines between Q1 and Q2. So this is how it's going to be. This is how the field lines can be indicated. Now, like I said before drawing this, I said electric field lines are centripetal for a negative charge. It means that for a negative charge, the line curved inward. Yes, it curves inward towards the negative charge. So you see, it comes toward the negative charge and it moves inward. But what's the meaning of, that's the meaning of centripetal. But for a positive charge, the electric field lines are centrifugal. They are centrifugal, meaning that they are moving outward, still in the form of a sickle, in the form of a sickle, but moving outward. So we talk of the centrifugal pathway. Without wasting of time, we're going to continue with Roman 2. Roman 2 says, determine the point on the line passing through the two particles at which the resultant electric field strength is 0. We have to determine a point between these two particles, between these two charged particles, where the electric field strength due to these two charges is going to be 0. Now, let us represent Q1 again. Q1 here, yeah, and Q2 and Q2 here. And we know this is the line. I needed a ruler to draw this. Thank God my hand is very straight. This is the line joining the two charges Q1 and Q2, and the distance between these two charges was given to us as 5.0 times 10 to the negative 2 meters. So now we are required to find the point on the line joining these two charges, a point on this line where the electric field strength due to these two charges will be 0. Indirectly, we are looking for a point on this line where the electric field strength due to Q1 and Q2 will cancel out each other. So for this to happen, it means that it will be at a certain point here. Let's say that point P is at a distance of x from Q1. Now let us see what is going to happen. We know Q1, we know Q2, and we know the distances, and we need to find this distance x, that position where the electric field strength will cancel out, and the electric field strength E1, meaning that electric field strength due to Q1 is going to be equal to, we know this as what, K Q1 over the distance, exactly the distance from Q1 to that point of 0 electric field strength due to Q1 and Q2, and that point we are indicating here as P, and the distance between Q1 and that point P is X, so divided by X squared. Yeah, that this is we are following the formula. Electric field strength is given by KQ on R squared, where R squared is the square of the distance between the charges or something. So now we have E1 as KQ1 on X squared, and let us name this equation 1. Then we are going to have E2 as well. E2 meaning that the electric field strength due to the charge Q2 is going to be KQ2 on. Now what is the distance from Q2 to that same point? It's no longer going to be X, because we know the total distance. We know the total distance as 0.05 meters. Yeah, this 5.0 times 10 to the negative 2 is 0.05 meter. And if this distance is X, then this one will be the total distance minus X, all that squared. So we are going to call this equation 2. Okay, for the electric field strength due to Q1 and Q2, meaning for E1 and E2 to cancel out each other and become 0, it means that at this point P, it means at P E1 is equal to E2. That is a simple logic. And if E1 is equal to E2, this means that E1 minus E2 is equal to 0. So let us evaluate that E1 will be equal to E2. If E1 be equal to E2, it means that KQ1 over X squared will be equal to KQ2 over 0.05 minus X, all that squared. This is the meaning. If E1 is equal to E2, it means that equation 1 will be equal to equation 2. And so, can we cross multiply? If we cross multiply this, we are going to have let us cross multiply and actually substitute the value of Q1 and Q2 at once. Then we already know that the K on the left hand side and the K on the right hand side are going to cancel out. What is K? K is the electric field constant, right? It is a constant, and it is the same for the charge Q1 and the charge Q2. They are just going to flip off. So we are left with Q1 on X squared equal to Q2 over X, or 0.05 minus X other squared. After we have flipped up this already, we have flipped off K. Now we fit in Q1. After cross multiplying, we fit in Q1 and Q2. So our resulting equation is going to be 4. This 4 is the charge Q1, which we had here as 4.0 microcoulomb. So we have 4. I take just the magnitude of that 4. Then 4 into 0.05 minus X all squared. I said E1 equal to E2, right? Equal to sorry for that. Equal to negative 3, then X squared. Yes, if we cross multiply and fit the values accurately, we are going to end up with this. And with this equation, what are we doing? We now need to solve for X. When we begin to solve for X in this equation, we are going to end up with this quadratic equation. We are going to end up with the quadratic equation 7x squared minus 0.04x plus 0.01 equal to 0. Now we are required to solve this quadratic equation for X to have the value of X. And how can we solve this quadratic equation? We can do this by the method of the formula method. We just feed in the formula X equal to negative b plus or minus the square root of b squared minus 4ac, all that divided by 2a. And if we do that, we are going to have x as 0.4 over 14 plus or minus I times the root of 0.12 on 14. If you do that correctly, you are going to have this. If you work this correctly, you are going to end up here. And so here we come to the end of the video. I hope you enjoyed the video. If yes, click on subscribe, like the video, share the video, and see you in the next video. Thank you for watching.